Hi everyone. The topic of today's session is error detection scheme, that is parity check. Quite interesting topic it is, and yes, it's very easy to understand as well. So let's start today's topic. Error detection. First of all, I want you to let you know about data transmission. So data transmission is sending the signal from sender to receiver, and this process is known as data transmission. We have a sender and receiver, and during transmission, if data has not been received correctly from one end to another end, that is known as error. And how to detect that error? We have different schemes to follow, and we are studying parity check today. So basically we have two types of parity check. One is even parity and one is odd parity. So as the name indicating that we have to do something with the even bits and then with odd bits. So how are we going to proceed about it? So let's start with the even parity, and we need to count the number of ones. Here you can see we have four number of ones, and number of ones are already even. So we are going to add 1 0 here. So the scheme we are applying on it is even parity. Let me repeat it again. In even parity we are going to count number of ones. If these are 1, these ones are even. Yes, 1, 2, 3, 4 even. So we need to add 1 0 here. How to calculate odd parity? So again we are going to count the number of ones. 1, 2, 3, 4. We have 4 ones, that is an even number. But as a scheme we are going to apply on parity, odd parity. So what are we going to add? We are going to add 1 here. So for further explanation, I have chosen an activity in which you need to calculate the parity bit for the provided data. So here it has been mentioned that we are using even parity. So how are we going to set the parity bit? So number of ones are 1, 2, 3, 4, 5. So number of ones are odd, but we need to implement even parity. So in order to make it even, I am going to write 1 here. Again, in this example, you can see we have 1, 2, 3, 4 means 4 ones, even ones. So no need to add any extra bit. So I'm just going to write 0 here. So one of the question I can solve from the odd parity. So let's try this question. 1, 2, 3, 4, 5, 6, 7. Already number 7 is an odd number. I'm just going to add 1 0 here. Got it? The rest of the question, students, you are going to solve it for me. And yes, you can share it in the comment box. Definitely, I will provide you the feedback accordingly. So, in next question, what they said that parity is already being calculated. You just need to confirm that is either it's correct or wrong. So, they are saying the scheme we are applying on it is even parity. Let's check this is our parity bit if it is correct or not. So 1, 2, 3, 4, 5, 6. So even parity and we have 6 number of ones. So our answer is correct. There is no error in this data transmission. Now even parity being used again, and yes, we have 1, 2, 3, 4, 5. So it means that our parity bit is wrong. So kindly solve rest of the question so that I can assess that if you have grasped the concept correctly or not. So let's proceed further to the next question. So for whatever we have done is for error detection, but definitely we need to correct the error as well. So for that purpose, we need to know about error correction. For error correction, I want you to understand the concept of parity byte. So as I've already discussed in my previous classes, that parity is basically a bit. In previous question, sorry, we have solved what is a parity bit. But when different parity bits combine, definitely these will be forming a parity byte. Here you can see, so this is our parity byte. So basically, we do call this whole data as a parity block method. Okay, parity block. So in parity block, you can see here parity bit, and then parity byte. So how are we going to correct the error during the data transmission? So let's try it. Again, it's a very simple thing. We just need to check the correctness of data, and then if it is not correct, then we will definitely correct it. So let's start from first column, right? So here we have 1, 2, 3, 4, 5. So the scheme we are using here is odd parity, and yes, 1, 2, 3, 4, 5. This column is correct. Now let's proceed further. 1, 2, 3, 4, 5. This column is also correct. 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, 7. Correct. 1, 2, 3, 4, 5. Correct. Odd number. 1, 2, 3, 4, 5. It's correct. 1, 2, 3, 4. Yes. We have to check this column. 1, 2, 3, 4, 5. So 1, 2, 3. This is also correct. Now we are going to check it row wise. So 1, 2, 3. This one is correct. This is our parity bit. We need to check the values of parity byte and parity bit. So for row 2, these are columns and these are rows, right? So for row 2, 1, 2, 3, 4, 5, 7, it's also correct. 1, 2, 3, this is correct. And 1, 2, 3, 4, this is, 1, 2, 3, 4. This is incorrect. So we need to look at this column number 4. Sorry, row number 4. 1, 2, 3, 4, 5. This one is correct. Then 1, 2, 3. Hopefully you are getting the idea that I'm just checking the number of ones. If these are odds, I'm considering it correct. If the number of ones in a stream is even, I am going to correct it. 1, 2, 3. So this is again correct. So 1 is correct. 1, 2, 3. 1, 2, 3, 4, 5. This is also correct. So what can we say here? That we have problem in this column, right? Let me draw it with some lighter color so that we can highlight it properly. Mm, yes. So we are having a problem in this column. Let me highlight it correctly so that, okay. So this column and this row. And at the junction of this column and row, yes, it's very obvious that this bit has not been transmitted correctly. So we have only two options, either 1 or 0. So if it is not 0, then definitely it must be 1. So we are going to correct this bit with 1. And yes, our whole data block has been transmitted correctly. And if there is any error, we have corrected it. And after correction, our data string is quite clear or free of error. Hopefully you got the idea of error detection and correction. For error detection, what we can do, we can just use the concept of parity bit. It's just showing us that either our data has been transferred correctly or not. And yes, for checking the data correctness, we have attempted this question. And for error correction, if you want to correct the error in data stream, we are going to follow the method of parity block. And what are we doing in parity block? We are checking if our parity byte is correct and our parity bit is correct. And if there is any problem at the junction of row and column, we will just identify that area, and then whatever bit is given there, we are going to reverse it and our data will be corrected. Hopefully you got the idea of parity block, parity bit and parity byte, error detection and error correction. See you in next section, inshallah, with check digit problems. How are we going to calculate the check digit? Till then, Allah Hafiz. Keep watching my video and subscribe my channel as well. Thank you very much.